Welcome back, students. Today we are going to start our next unit, and that's going to get us into lines. So before we start graphing lines, we need to talk about a very important concept with lines, and that's rate of change. All right, rate of change is the amount that a graph increases or decreases per 1 unit. So how much are you going to go up, and how much are you going to go down, and how much are you going to go left, and how much are you going to go to the right? That rate of change of a line is commonly referred to as its slope. Okay, and we use the letter M to represent slope. Sometimes we'll express slope as what's called the rise over the run. So again, rise just means how much do you go up or how much do you go down from point to point. And run means how much do you go left, how much do you go to the right from one point to the next. And it's written as a fraction, right? So all of these right here are ways to represent slope. It's the letter M, it's the phrase rate of change, it's the word slope, or it's rise over run. And in a little bit, we'll also introduce a formula that we'll also have. But for right now, we are going to look at graphs to determine the slope of the line. So the way that you read a graph is from left to right, just like you read a sentence. Determine the slope of a line. Okay, determine the slope. We read from left to right. So when I look at this graph, the left side of the graph, and I look at the graph on the right, okay, I see that I'm starting up here at the top and I'm ending down here at the bottom. So first thing I should do is determine, am I going up or am I going down? So if I start on the left side and I end on the right, I'm going down, which means that this rate of change, this slope, is going to be negative. So what I can do from the very beginning, when I write my slope down, I'm going to put a negative sign out in front. Next thing that you should do is count from one point to the next. Now, these points are kind of highlighted, okay, they're exaggerated. Sometimes they won't be, and you're going to have to pick out nice points that are on the line. What is the rise? That means how much up or how much down do I go? Okay, it doesn't matter which one you do because we already determined the slope's going to be negative. Now all we care about is how many. So it's kind of like your absolute value. What's the distance? How far away are they? All right, so to go from this point down to this point, if you want to, you can make a right triangle out of it. All right, so this is the line. This is the y value where this ordered pair is at. It's down at -4. So how many do I have to go down in order to get there? So I go down 1, 2, 3, 4, 5, 6, 7, 8. So my rise is 8. Okay, whether I count from down to up or up to down, I don't care about negative or positive. I count how many spaces there are, and that's 8. Run is how much do you go from the left to the right or right to left. Same thing. We don't care about positive or negative. We already determined the slope is negative. We just count how many spaces we go over from one to the next. So we go over 1, 2, 3, 4, 5, 6. So the run is 6. So our formula is rise over run. So I'm going to make a fraction now, and I'm going to write 8 over 6. Negative sign's already there, so this slope is -8 over 6, and always reduce your fraction as much as possible. Okay, so top is even, which means it's divisible by 2. Bottom is even, which means it's divisible by 2. So final answer, this slope is -4 over 3. On the next one, when we look at this line from left to right, I start on the left, I end on the right, and when I go from my start to my end, I'm going up. So my slope is positive. We don't actually put a plus sign when we say positive. Okay, so I'm just going to draw in my fraction bar. I'll make this one be my fraction bar. Now I need to determine the rise. So from one point to the next, how much do I have to go up? So if I make a right triangle out of this, I go up 1. So my rise is just 1. And I go to the right, 1, 2, 3, 4, 5. So writing this as a fraction, rise over run, this would be 1 over 5. And again, it's positive because my line is going up. My next two cases are going to be a little bit different. Notice that these first two cases, they were either going down or going up. My next two cases are a little bit different because these lines, okay, here we have a horizontal line, just goes left and right. doesn't go up or down any, just left and right. And this one just goes up and down, it doesn't go left or right any. All right, so like I said, this was called a horizontal line. And this line we should be familiar with because we've had the vertical line test. And this is a vertical line itself. All right, so first we need to do is we need to determine, okay, are we going up or down? We're not going to do that for a horizontal line or a vertical line. We're not going to determine if we go up or down, okay, for the slope. Instead, what we're going to do is we're still going to count the rise and the run. So remember, rise means how much do you go up or down? So how much do I go up to get to this next point? And the answer is I don't go up at all. We don't go up or down at all. So the number that represents that would be 0. However, the run, how much do we go over? We go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So writing this as a slope, rise over run, this would give us 0 over 10, which if you need to, you can put that into a calculator, but that reduces down to just 0. So no matter where this horizontal line is, whenever you have a horizontal line, the rate of change is either going to be 0 or this other word, which is called undefined, and a horizontal line is always going to have a rate of change or a slope of 0. Because we don't go up or down any, but we go left and right forever. So that means the vertical line is going to have a slope that's said to be undefined. And here's why. When you count your rise and your run, so going from this point to this point, I have 1, 2, 3, 4, 5, 6. But when you count the run, how much do you go left or right any? It's 0. All right, so my slope is 6 divided by 0. Now, take a minute and pause this video and type that into a calculator and see what it tells you. It depends on what calculator you're using, but if you're using Desmos, it tells you undefined. If you're using another calculator, it might say error, which is a word. So the way that you can remember this is if you type it into a calculator, it gives you a word answer. The only slope that we have that's a word is this undefined. It is not possible for us to divide by 0. So if you ever have a run, a vertical line, which means that the run, we don't go left or right any, then that means that you are going to have a slope that is undefined. All right, so this is what we'd put for our slope. So always make sure that you reduce as much as possible. So you might reduce down to 0, you might just reduce down to a fraction, or you might just put the word undefined. So these are our 4 possibilities. There are only 4 possibilities for what you can have for slope. You can have a graph that goes down, which decreases, which will have a numerical answer, but with a negative in front. You can have a graph that goes up, which means you'll have a positive slope with a numerical fraction or possibly reduced to an integer. And then you can have a horizontal line, which means the slope will always be 0, or a vertical line, which the slope is always undefined. This one right here, this is the only one of our graphs that is not a function. All the other ones would pass the vertical line test, but a vertical line itself would fail the vertical line test, making this the only type of linear graph that is not a function. All right, let's continue talking about slope, but now, okay, notice M is your rate of change, your slope is your rise over run. Now let's introduce the formula. So if we are given ordered pairs, all it takes is 2 points to make a unique line. So all we need are 2 ordered pairs from a line. Sometimes you'll get to choose what those are, sometimes they will be provided for you. But when you have 2 ordered pairs, remember in an ordered pair, it's always the x coordinate followed by the y coordinate. So when we label this, we're going to have the x coordinate followed by the y coordinate. We're going to have the x coordinate followed by the y coordinate. But I want to get more specific than that. Because I used x twice, these are 2 unique x's. What I need to do is I need to use what are called subscripts. So I'm going to place little numbers to the bottom right of these variables. I'm going to use 1 because this is in the first ordered pair, and for this one I'm going to use 2 because it's in the second ordered pair. So this is going to be y1 because it's in the first ordered pair, and this is going to be y2 because it's in the second ordered pair. And now what I'm going to do is I'm going to rewrite my formula, but when I rewrite my formula, I'm going to replace the y2s and the y1s and the x2 and the x1. Those values, I'm going to replace them with my values that were in the problem that were given to me. All right, so my slope, my m, is equal to y2. That's my formula right up here. So instead of writing y2, I labeled 8 as y2. So I'm going to replace y2 with 8. Minus, that's in the formula, so I'm going to write the minus sign. Next is my y1, which in this case it's negative 10. So I'm going to write down negative 10. The minus comes from the formula. Negative 10 is the value of y1. x2, so here's my x2. It's 5 minus my x1. x1 is 3. So now I need to evaluate. And feel free to type this into Desmos and have Desmos evaluate this for you. But if you take 8 minus negative 10, that's really the same thing as taking 8 plus 10. Over 5 minus 3, well, that's just 2. So 8 plus 10 is going to give me 18. Divided by 2, that's going to give me a slope of 9. Okay, if you want to write this as a fraction, which writing slope as a fraction is usually very important, so you identify the rise is 9, the run would be 1. So the slope is 9. If you want to write it as a fraction, you could to help you with graphing. The rise is 9, the run is 1. All right, but final answer, as simplified as possible, the slope is equal to 9. Next one, we'll do the same thing. We'll label our first x-coordinate as x1. We'll label our first y-coordinate as y1. We'll label our second x-coordinate as x2 and the second y-coordinate as y2. And then we plug these values into our formula. So m is equal to y2 is 15 minus, which is in the formula, y1, once again, is negative 10, divided by x2, which is negative 15, and x1, so then minus x1, which is 6. So minus a negative will again change to plus. So I'll take 15 plus 10, which will give me 25, over negative 15 minus 6 is going to give me negative 21. I try to reduce this as much as possible if I can, okay, but I don't believe that there's anything that 25 and 21 are both divisible by, so this would be my final answer. Now, when I write this answer, I can either put the negative on the bottom with the 21 like I had before, or I could put the negative up in the numerator, or I could put the negative out in front. Notice that however I write it, either of these three ways, there's one negative sign. It's either on the bottom, it's on top, or it's out in front. If I tried to put a negative on top and bottom, that'd be a negative divided by negative, which would change this to positive. All right, but all three of these ways, okay, it's up to you how you want to write it. All three of these fractions would be equivalent. Our next example, we'll do the same thing, where we'll have x1, y1, x2, y2. And we go and we plug these into our formula. So our y2 is 8 minus negative, and then that y1 value was negative 10. So minus from the formula, negative 10 because of y1. And then x2 is 5 minus x1 is 5. So minus negative will change to plus. We will have 8 plus 10, which will get us 18. 18 divided by 5 minus 5 is 0. 18 divided by 0, type it into a calculator. Depending on the calculator you use, it will either say error or undefined. Either way, it's a word answer, and the only word for slope that we have is undefined. If we were to graph this, we would get a graph of a vertical line. On our next one, we have x1, y1, x2, y2, and we'll plug it into the formula. M is equal to y2, which is 5, minus y1 is 5, divided by 8 is our x2, minus x1 is negative 10. Minus a negative changes to plus, and this will give us 5 minus 5, which is 0. divided by 8 plus 10 is 18. Type this into a calculator, 0 divided by 18, and it will reduce it down to 0. So if we plotted these 2 points and connected them, this line would be a horizontal line. Our last type of problem is by far the hardest problem that we have. Okay, and there are a few ways that you can go about this. If you wanted to, you could plot the point that is already given to you on a coordinate plane, and then use your slope to move to the next point, and continue to move and figure out, okay, what is my ordered pair that this line goes through that has a y-coordinate of -2? So one way you can do this is graphically. But I'm going to show you on this video how to do so just algebraically using the formula. So every time I was using my formula in these problems up above, I was labeling x1, y1, x2, y2. I labeled everything that I could. So I'm going to do the same thing here. Here are my 2 ordered pairs. I'm going to label x1. I'm going to label y1. I'm going to label x2. I'm going to label y2. Okay, but the difference is I'm also given my slope. The slope of this line is -3/2. We know that slope is the letter m. Okay, so here is our formula. M is equal to y2 minus y1. It's the change of y's over the change of x's, which is x2 minus x1. So when we go to replace these values or plug them into our formula, okay, I'm going to have y2 gets replaced with -2 minus, because that's the formula, y1 is 4 over x2 is r minus x1 is -1. All right, so minus a negative, I can change that to a plus. All right, but notice over here, I have a variable. I have an unknown value. My numerator I can evaluate. -2 minus 4. Well, -2 minus 4, those are the same sign. So 2 plus 4 is 6. They're both negative, so this will be negative. Over r plus 1, I can't combine those. Those are unlike terms. This is a variable and this one doesn't. So it just needs to stay r plus 1. But what I do know, okay, so something that I didn't have before is I know the slope. The slope is supposed to be -3/2. Again, I could either have that negative on top or on bottom or out in front, right? But the slope is supposed to be -3/2. So what I need to do is I need to figure out what is this value of r that's going to give me a slope of -3/2. So you could use some guess and check. However, guess and check, if it doesn't come to you right away, it would be nice to have a process where you don't need to use guess and check to try to figure out what number I plug in here, which would get this fraction reduced to -3/2. So the process would be to solve an equation. Okay, here we have a fraction, here we have a fraction. So what we're going to do is we're going to multiply to get rid of the fraction. A fraction means divide. So if we want to undo fractions, we undo division with multiplication. So with this fraction, I was dividing by 2. So what I'm going to do is I'm going to multiply both sides by 2. So I'm going to multiply by 2, and I'm going to multiply by 2. Multiplying by 2 and dividing by 2 cancels out. Okay, so I'm going to come over here now and show my work. So on the left-hand side, times 2 divided by 2 canceled, I'm left with -3 equals, on the right-hand side, I'm going to multiply by 2. Well, that's a fraction, so I'm going to turn times 2 as a fraction as well. And if you remember back to our first unit, when you multiply with fractions, you just multiply the numerators and you multiply the denominators. So -6 times 2 is -12. Over, my denominator stays the same, r plus 1. Now what we're going to do is we're going to get rid of this denominator, which means I need to multiply by r plus 1. If I'm going to do that on my right side, I'm going to need to multiply the left side times r plus 1 as well. Now on the right-hand side, I multiply by r plus 1 and divide, so those cancel each other out. So on my right-hand side, I'm just left with -12. On the left-hand side, I'm going to have to multiply. I'm going to multiply -3 times r, and I'm going to multiply -3 times 1. So this is going to give me negative 3r, and then negative 3 times 1 is negative 3. And now I have myself an equation that does not involve using fractions. So I split the left-hand side from the right-hand side. R is being multiplied by negative 3, and we are subtracting 3. So get rid of what's unattached to R first, because it's easier in life to get rid of things that you're not attached to. So we're going to get rid of the minus 3 by adding 3 to both sides. These will cancel out, leaving you with negative 3R is equal to negative 12 plus 3 is negative 9. And then divide both sides by negative 3, and we get that R is equal to positive 3. Okay, so we could double check our work over here. Use our slope formula. Y2 is negative 2 minus Y1, which is 4, divided by X2, which now we figured out R is 3, minus negative 1. So minus negative 1. So on top, negative 2 minus 4 will give us negative 6. But in the denominator, 3 minus negative, we don't have two signs in a row, so we'll change those to a plus. 3 plus 1 would give us 4. Reduce, top and bottom are both divisible by 2. Again, feel free to use Desmos. Desmos can reduce fractions for you. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. So we get a slope of negative 3 over 2, which was given to us originally. When did we get a slope of negative 3 over 2? When R was equal to 3. All right, and there you have it. That is our first day of working with slopes.